Hello, my name is Sanjay, and for ENGG851 Assessment Task 3, today I am going to present in front of you a topic called Testing of New Lubricants in Sheet Metal Forming. Now let us see what is a sheet metal. A sheet metal is nothing but a metal which is processed in industry into thin sheets and plates, and it is used to give a required shape and size according to the customer's requirement. Foaming is defined as a process of plastic deformation of that sheet by using compressive or tensile stresses on it. It is just that we don't have to change the mass and the weight of the sheet. So, sheet metal forming is defined as a process in which compressive, tensile, and combined stresses are used for plastic deformation of the sheet metal without changing its shape and without changing its weight and mass. So, this plastic deformation of the sheet metal is carried out by using hydraulic press, or you can use a mechanical press too. The figure shows a hydraulic press, and to change the shape and the size, in the hydraulic press we use dies. As you can see in this above figure, there are two dies. These dies are used for for molding the or changing the shape of the sheet metal, and these two dies are used, and in between there is a sheet. So the hydraulic press, by using the hydraulic press, we can just use the compressive strength and change the shape, and accordingly we won't change the mass and the weight of the sheet. Uh, to get the various shapes on the sheet, we can change the molds according to the requirement, and by changing the molds again we can use them in the hydraulic press and get the required results. So galling. A galling is defined as a wear which is being caused on the tool and the workpiece by the abrasive between the sliding of the tool and the workpiece. When the tool slides on the workpiece, there is a wear because of high friction between the tool and the workpiece. So this wear is called as galling. So as we have seen in the previous slide, as we can see in this slide, that this is a sheet metal, and there are some lines on the sheet. So this is because of this is the galling, that is because of the high friction between the tool and the workpiece. In this figure we can see the before and the after scenario in the tool. In the before scenario we can see that the tool is clear, but in the after scenario we can see that there is a bit of tool wear in the figure, because this is because of the continuous use of the tool in the sheet metal forming. So to get rid of this galling, sheet metal forming industries are using lubricants such as chlorinated paraffin oils. Now, the present scenario is that presently the chlorinated paraffin oil is used in a large amount in sheet metal forming industry, because it has very good tribological properties. That is, it can reduce wear, it has low friction, it has better lubricity, it provides smooth surface, it increases the sliding length between the tool and the workpiece, and it reduces galling. But with the pros comes the con of the chlorinated paraffin oil. That is, it is environmentally hazardous and it is not good for the human health. Taking in consideration the human health, there are like you get skin irritation and eye irritation if you use the oil repeatedly. And in the environmental conditions, if you see that chlorinated paraffin oil has low solubility, so it is not soluble in water, and if it is not soluble in water, it is dangerous for the fish and the animals inside in the water. And again, it has a drawback in the air, because chlorinated paraffin oil is produced by using chlorine gas, which is being reacted with paraffins at a temperature of 80 to 100 degrees Celsius. So this chlorine, which is present in the chlorinated paraffin oil, is dangerous. There is a need to change the chlorinated paraffin oil into an environmentally friendly lubricant, which has good tribological properties and which would reduce galling. A good lubricant actually has good tribological properties. That is, it has low friction, it has less wear of the tool and the workpiece, it can withstand high temperature, it can give smooth surface roughness. So as the research was carried out, it was found that there are polymer based lubricants present which can withstand and give good efficient results, but polymer based lubricants individually can't perform well, so they have to be with an additive and a coating on the tool, which is being used in the sheet metal forming. The polymer based lubricants which were found are Pifner 1, Pifner 2, Pifner 3, Kental L6250, mineral oil CR5, polyoxymethylene PMO in molybdenum disulfide is MOS2, and additives which were found are silicon emulsion, colloidal silicate, and non-ionic surface stunt. Now, these polymer-based additives can be added. These polymer-based lubricants can be added with the additives to improve the performance. And the coating can be applied on the sheet on the tool in the sheet metal forming, which comes in contact with the sheet metal. So the coating was found as DLC, that is diamond-like carbon, titanium nitride, and titanium carbon nitride. So the combination of these polymer-based lubricants, the additives, and the coating coming together would give a very good result. So this combination was tested in 3 tests, that is bending under tension test, drawbend test, and strip reduction test. Through journals and articles and conference paper effort in the case study, there were various combinations used in the of the lubricant, of the additive, and the coating. For example, if we take a research paper which discussed about the polyoxymethylene in molybdenum desulfide, that is PMO in MOS2, it stated that if PMO is present 1% in MOS2, its tribological properties are very good. It can withstand high temperature and it can produce smooth surface without any galling. But if PMO in MOS2 is more than 1%, that is even if it is more than like 1.3 or 4%, it cannot withstand its tribological properties are disturbed. It cannot withstand high temperature because there is a film breakdown of the lubricant, and this results into more friction between the tool and the workpiece because there is no lubricant present over there, and then it results into galling. So the research question which was after the survey was, which polymer based lubricant will satisfy the tribological properties and reduce galling, and thereby give smooth surface roughness, withstand higher temperatures, and increase the sliding length between the tool and the workpiece. So a research design was conducted, and a lubricant, a additive, and a coating was selected. The lubricant, additive, and coating selection was based on the individual characteristics and properties of the lubricant, additive, and coating, and their performance in the journals and the conference papers studied till today. So to answer the research question, a lubricant called Pifner 1, and additive called as silicon emulsion, and a coating called as DLC, that is diamond-like coating, was selected. Pifner 1 was selected because it has a viscosity of 205 CST at a temperature of 400 degrees Celsius, which shows that it can resist deformation even at higher temperature of 850 degrees Celsius. So even if this lubricant is used at a temperature of 850 degrees Celsius, there would be no film breakdown, and if there is no film breakdown there, it can perform well till 850 degrees Celsius, and there would be no galling as there is no film breakdown. Silicon emulsion and additive, which is used as an additive in the lubricant, it has very good properties such as it is heat stable, it is inert, and it is non-toxic, so it is not non-hazardous to the environment, and it can withstand temperatures at up to 800 degrees Celsius. Emulsion, that this is silicon emulsion as an additive, is performing very good as a catalyst, you can say, in the lubricant, so that it improves the performance of the lubricant when it is being used. A diamond-like coating was selected because diamond-like coating is a well-known for its friction reduction and excellent tribological properties, and it can withstand very high pressure in sliding and rolling mechanisms. So this combination of lubricant, additive, and coating was tested by 3 tests. So the first test is bending under tension test. From the figure we can see that there is a hydraulic press which is being used in the bend and the tension test, that is the butt test, and by using this combination it was found that there was an increase in the sliding length, because as we know that Pifner 1 can resist to deformation up to 800 degrees Celsius. So as it is not deforming up to 800 degrees Celsius, there is no film breakdown. So there is no film breakdown till 800 degrees Celsius, and there is a good sliding length between the tool and the workpiece. So the tool and the workpiece, there would be a good sliding length, and it won't break down. That film won't break down, and up to 700 degrees Celsius, because this process achieves a temperature about 700 degrees Celsius, and our combination has a temperature of 800 degrees Celsius. So and the low friction due to DLC coating, there would be low friction in the process because DLC coating is well known for its low friction coefficient, and again it can be used at high pressures in sliding and rolling. So DLC is playing a very important role as DLC coating is on the tool. And by combining all this effect of the tool and the workpiece and the lubricant, additive and the coating, we get a smooth surface roughness and no galling will be detected. Now going through the second test, that is a drawband test. A drawband test is majorly a test in which the roller mechanism is used in the sheet, and the sheet goes through the roller mechanism. So there is a lot of continuous turnings in the mechanism, which makes the up to 360 degrees Celsius, 360 degrees you can say. So so there is a rise in temperature. So this rise in temperature is about 800 degrees Celsius, but this mechanism is totally, the combination is can withstand about 850 degrees Celsius because we are using silicone emulsion as an additive which can withstand temperature of about 850 degrees Celsius. So the combination would increase the sliding length of up to 270 mm of this, and there would be no film breakdown. And taking all the properties and the of the lubricants, we can see that we can obtain smooth surface roughness and there would be no galling. The third test is strip reduction test. The strip reduction test you can see over here is it has two tools, that is a flat base and the cutter, and there is a strip on, and there is a metal strip on the top. So there is a lot of friction between the tool and the workpiece when the process is going on. So it can so the temperature of this process goes about to 650 degrees Celsius, but as the combination can withstand a temperature of up to 850 degrees Celsius, I can say that we can increase the sliding length up to 300 degrees Celsius. We can improve the sliding length up to 300 mm, and we can withstand a temperature of 650 degrees Celsius. And by the combination, we can improve the surface roughness and there would be no galling. The limitations of this research was as there was less time and the sheet metal forming process is a vast area. I couldn't go into much details, and I just used that is 6 polymer based lubricants, 4 additives and 3 coatings, and there was no research being carried out on the chlorinated paraffin oil. Chlorinated paraffin oil is very well known for its tribological properties. It is just that it is hazardous to the environment. Research should have been carried out to talk about how a non-hazardous lubricant, that is chlorinated paraffin oil, can be converted into a non-hazardous one because it has very good tribological properties rather than the polymer based lubricants. The laboratory tests were being carried out. So the laboratory tests are different from the production scenario, and the tests were carried out only on 3 things, that is butt end tension test, drawband test and strip reduction test. The conclusion is that Pfiffner 3 as a lubricant, then silicone emulsion as additive, and a diamond-like coating as a coating performs very well. It reduces galling, provides smooth surface roughness, gives low friction coefficient and reduces wear. Any questions?
Yeah, my question is that is this the only combination of lubricant, additive, and coating that reduces galling?
This is not the only combination. If you go into much detail, you would actually get a good combination. Pfiffner 3 has very good tribological properties. It is just that I have only gone through 3 additives. So if you get a very good additive, you can go with Pfiffner 3. And no doubt diamond-like coating is a very good coating on the tool. So go ahead with the diamond-like coating tool. Thank you. Thank you for your attention.